Hi everyone! Today we'll be proving trigonometric identities. We will solve these 5 trigonometric identities on the board. First, let's start with 1 minus cosine squared x times cosecant squared x equal to 1. So, from the Pythagorean Theorem identity, we know that sine squared x plus cosine squared x is equal to 1. So that means if we subtract cosine squared x from both sides of the equation, we will get sine squared x equal to 1 minus cosine squared x. So we can replace that on our equation. So that would be sine squared x times cosecant squared x. Now, from the reciprocal identity, we know that cosecant x is equal to 1 over sine x. So that means we can replace cosecant in our equation, and that becomes sine squared x times 1 over sine x squared. So if you just distribute squared, that will become sine squared x over 1 over sine squared x. And then we can cancel sine squared x, and our remaining value will be 1. Now let's go to the second trigonometric function. So that's tangent x sine x plus cosine x equal to secant x From the quotient identity, we know that tangent x is equal to sine over cosine. We can replace this in our equation, and that becomes sine x over cosine x times sine x plus cosine x. And then we will multiply the two signs, so that becomes sine squared x over cosine x plus cosine x. Now, in order to add these two terms, we have to make cosine x with the denominator of cosine x. So that means we will multiply cosine x to the numerator and denominator, and that will give us sine squared x plus cosine squared x all over cosine x. Now, again, from the Pythagorean Theorem identity, we know that sine squared x plus cosine squared x is equal to 1. That means that we can replace this in our equation, and that becomes 1 over cosine x. And then the reciprocal identity says that secant x is equal to 1 over cosine x. That means that we can write this simply as secant x. So that's how we prove this equation. Now let's go to the third one. That's 1 minus cosine x times 1 plus cosine x times 1 plus cotangent squared x equal to 1. 1 minus cosine x and 1 plus cosine x, if we use FOIL, we will get 1 plus cosine x minus cosine x minus cosine squared x. And then cosine x zeroes out, so that leaves us with 1 minus cosine squared x plus cotangent squared x. Now, from the Pythagorean identity again, we can say that secant sine squared x sine squared x plus cosine squared x is equal to 1. So that means if we transfer cosine to the right side of the equation, we will get sine squared x equal to 1 minus cosine squared x. That means that we can rewrite 1 minus cosine squared x as sine squared x. So that becomes sine squared x times 1 plus cotangent squared x. Now let's try distributing sine squared x to the rest of the equation, so that becomes sine squared x plus sine squared x cotangent x. Now from the quotient identity, we know that cotangent x is equal to cosine x over sine x. So that becomes sine squared x plus sine squared x times cosine squared x over sine squared x. Here we can cancel sine squared x, and that leaves us with sine squared x plus cosine x, which we know is equal to 1. So that means that our answer is equal to 1. Now let's go to the fourth equation. So our fourth equation is 1 over 1 minus sine x equal to cotangent x over cotangent x minus cosine x. Now from the quotient identity, we can say that cotangent x is cosine over sine. That means that we can replace cotangent x on our equation with cosine x sine x. So that becomes cosine x over sine x all over cosine x over sine x minus cosine x. And then we can simplify the denominator by making the cosine x over cosine x over sine x over cosine x minus cosine x times sine x over sine x. Now we can proceed to getting the reciprocal of our denominator and then multiplying the rest of the fraction. So that becomes cosine x over sine x times sine x over cosine x minus cosine x sine x. Sine x cancels out, and if we try to rewrite that, that becomes cosine x over cosine x minus cosine x sine x. That means that on our denominator, we can factor out cosine x. So if we factor it out, we will get cosine x times 1 minus sine x. Here, cosine x will be cancelled, so there we prove that this function is equal to 1 over 1 minus sine x. Now let's go to the last equation, which is cosine squared x over 1 minus sine x equal to 1 plus sine x. So let's try to work using the Pythagorean theorem. So that's sine squared x plus cosine squared x equal to 1. So that means if we subtract sine squared x on both sides of the equation, we will get cosine squared x equal to 1 minus sine squared x. So we can rewrite the numerator as 1 minus sine squared x all over 1 minus sine x. Now, 1 minus sine squared x is a perfect square binomial. It is 1 plus sine x times 1 minus sine x. That means that we can rewrite this whole thing as 1 plus sine x times 1 minus sine x. And then the denominator is 1 minus sine x. Here we can cancel out sine, 1 minus sine x, and that leaves us with 1 plus sine x, and that will be our answer.